Now see next question, question number 17. Prove that the two vectors whose direction cosines are given by the relations am plus bm plus cn equals to 0 and fmn plus gnn plus hlm equals to 0 are perpendicular if f by a plus g by b plus h by c equals to 0. So this problem is not difficult but lengthy, so I write the solution first and I explain one by one. So see here, see the first step, given part we write here, first equation al plus bm plus cn equals to 0. So first equation we represent by 1 and the second equation fmn plus gnn plus hlm equals to 0 we represent by equation number second. Now see from equation 1, so from this equation 1 we find the value of n in terms of lm. So we keep cn as it is and transfer these two terms to right hand side. So we get minus al minus bm on right hand side. Then we take minus sign common. So we write both the terms as plus al plus bm. Now transfer this c to right hand side. So we get n equals to minus al plus bm upon c. We denote that as equation number third. Now we substitute this value. So for reducing the n, we substitute n in terms of lm. So we write here substitute this value of n in equation second. We get, so we substitute this value n in equation number second. So for that we take n common from this equation second first. So we write equation second here fm plus gl into n. Here we take n common from this. So we write fm gl. So write fm plus gl taking n common. If this h l m as it is equals to 0. Now we replace the value of this n by this minus al plus bm upon c. So replace this n by minus al plus bm upon c. Now multiply both terms by c. When we multiply by c to first term, so c get cancelled and multiply this second term by c, we get c h l m. So I write here c h l m and here we take minus sign at first position, then this fm plus gl into al plus bm, fm plus gl into al plus bm. If this hl after multiplying by c we get chlm equals to 0. Now multiply these two brackets. So first we multiply these two brackets. So multiply by fm to f we get a f m l. Then multiply by fm to this bm. So write this b as first position. So b into f into m into m square. Then multiply by gl. So gl into al we get a into gl square, a into gl square. Then multiply by this gl to bm. So write b first. So b into glm, b into g into lm plus chlm. Now here lm, here is also lm and here is also lm. This ml can be written as lm. So we take ml common. So right here, therefore ag l square plus am plus bg minus ch lm, because we take lm common. So when we take ml common from this, remaining term is af. When we take lm common from this, we get plus bg. Then we take lm common here plus ch. Here is sign is negative. So when we multiply by minus sign to each term, so all these terms get negative. So we transfer this minus sign to right hand side, or we can multiply by minus sign. So this first bracket terms becomes positive and this second term becomes negative. So I write here minus ch. You can add one step more also. Plus b of m square. This b of m square and this agl square as it is. So So AgL square we write at first position. This AgL square we write at first position, and this BM square we write at third position. Now this is equation number 4. Note that both L and M cannot be 0. Now see here, if Lm are 0, from this equation third, when L is 0, M is 0, so in numerator 0 plus 0, we get 0. 0 upon any number is 0. That means we get n equals to 0. And we know the condition L square plus M square plus N square equals to 1. So see here, note that both L and M cannot be 0, because if L equals to M equals to 0, then from equation 3 we get n equals to 0. How get n equals to 0? We already discussed here. When we replace L by 0, so we get 0. When we replace this M by 0, we get 0. 0 upon C, that means 0 upon any number equals to 0. That means we get n is equals to 0. So which is not possible, because L square plus M square plus N square equals to 1. Let us take M not equal to 0. So we take here M not equal to 0. Then divide equation 4 by M square. Why we discuss this condition? Because we have to divide each term by M square. So we discuss whether we can write M equals to 0, N equals to 0, or L equals to 0 or not. So we divide each term by M square. So divide by M square. So we write Ag into L square by M square. This as it is Lm by M square plus Bf into M square by M square. So here we write L square M square in 1 square. This 1 M square get cancelled. So we write L by M. Here M square get cancelled. So we get Bf equals to 0. Now this is quadratic equation in L by M. So we write here, this is a quadratic equation in L by M. Now if L1 M1 N1 and L2 M2 N2 are the direction cosine of two lines given by equation 1 and 2. Now here is two lines. If we consider L1 M1 N1 and L2 M2 N2 are the direction cosines of that two lines, then L1 upon M1 and L2 upon M2 are the roots of quadratic equation. Now we have to use this concept. We know that if quadratic equation is ax square plus bx plus c equals to 0, and if we consider alpha and beta are the roots, we know that sum of the roots is equals to minus b by a, and product of the root equals to c by a. So we have to find the value of c and a, or we have to find the value of ABC from this quadratic equation 5. So compare this, we get here, if we consider here, I write here in capital form, so we have to write minus here, minus c by a, b by a, so we write b by a, and here capital C by a. Now we have to find the value of ABC. Now compare this. Here we get value of A, capital A is equals to small ag. Value of B, capital B is equals to AF plus BG minus CH. And value of capital C is equals to BF. Now we have to use this concept. If we consider L1 upon M1 and L2 upon M2 are the roots, then their product must be equals to C by A. So therefore we write in place of alpha and beta L1 upon M1, L2 upon M2. So we write here, therefore L1 upon M1 into L2 upon M2 is equals to C by A. Value of C is BF. Value of A is AG. So in this way we write L1 upon M1 into L2 upon M2 is equals to BF upon AG. So we rearrange this because we require F by A plus G by B plus F by C equals to 0. So we write this as L1 into L2 upon M1 into M2 is equals to So we require F by A and G by B. F by A, so I rearrange this F by A into B by G. So we write this B by G in denominator as, we write this as F by A upon G by B, because we required F by A plus G by B. Now you can transfer this in one side. So we write here L1 L2 into G by B So we write this as L1 L2 upon F by A equals to M1 M2 upon G by B. Similarly, we can show L1 L2 upon F by A equals to N1 into N2 upon H by C. So from this we write, therefore L1 L2 upon F by A is equals to M1 M2 upon G by B is equals to N1 N2 upon H by C. Now suppose this is equal to lambda, therefore we write L1 L2 is equal to lambda into F by A, M1 M2 is equal to lambda into G by B, and this N1 N2 is equal to lambda into H by C. Now these two lines are perpendicular given. We have to find that condition. So we write here, since lines are perpendicular, therefore by condition L1 L2 M1 M2 N1 N2 is equal to 0. That means this value sum equal to 0, that is lambda into F by A plus lambda into G by B plus lambda into H by C is equal to 0. Therefore now see next question number 18. If A of 1 2 3 and B of 4 5 6 are 2 points, then find the foot of the perpendicular from the point B to the line joining the origin and the point A. So first we draw diagram. So first we draw a figure here. Here point B, whose coordinates are 4 5 6. We have to find foot of perpendicular from point B. So here we consider foot of perpendicular as M, and foot of perpendicular on the line joining the origin and the point A. So this is origin O and this point A. So this BM is perpendicular to this OA and M is foot of perpendicular. So see how to write the answer. Here we have to find the coordinate of this point M. Let M be the foot of perpendicular drawn from B to the line joining O and A. So we have to find the coordinate of foot of perpendicular. So we consider coordinate of point M as XYZ. Let M equals to XYZ. OM has a direction ratios. So we calculate the direction ratios by using the concept x2 minus x1, y2 minus y1, z2 minus z1. Suppose here this point M as x2, y2, z2 and this point B as x1, y1, z1. So we write the coordinate of point M as xyz, and for calculation we consider this xyz as x2, y2, z2 because we know the direction. ratios are calculated by using the formula x2 minus x1, y2 minus y1, z2 minus z1. So OM has a direction ratios x minus 0, y minus 0, z minus 0, that is xyz. We calculate the direction ratios of OM first. OA has a direction ratios. We calculate direction ratios of OA. So we get here 1 minus 0, 2 minus 0, 3 minus 0, that is 1, 2, 3. But O, M, A are collinear. Now these 3 points are collinear. So we write the ratios in proportion. So we write x by 1 equals to y by 2 equals to z by 3 equals to k. Therefore we write x equals to k, y equals to 2k, z equals to 3k. Therefore we write coordinate of M in terms of k as k, 2k, 3k. BM has a direction ratios. Now we calculate the direction ratios of BM. Once we know the coordinate of M, so in place of xyz we use this k, 2k, 3k. So we write here k minus 4, then 2k minus 5, then 3k minus 6. That is by using the formula x2 minus x1, y2 minus y1, z2 minus z1 for the direction ratios. So the direction ratios of this BM are k minus 4, 2k minus 5, 3k minus 6. Since BM is perpendicular to A, now these two are perpendicular to each other. So using the concept A1 into A2 plus B1 into B2 plus C1 into C2 equals to 0. So we write here this 1 into k minus 4 plus 2 into 2k minus 5 plus 3 into 3k minus 6, because the direction ratio of OA are 1, 2, 3 and direction ratios of BM are k minus 4, 2k minus 5, 3k minus 6. That means here value of A1, B1, C1 is A1 is 1, B1 is 2, C1 is 3, and value of A2 is k, B2 is 2k and C2 is 3k. So we substitute here values. Therefore after multiplying by 1 we get k minus 4, after multiplying by 2 we get 4k minus 10, after multiplying by 3 we get 3 into 3 9k, 3 into 6 that is minus 18. So add the k terms. So we write k plus 4k 5k, 5k plus 9k that is 14k, and then minus 4 minus 10 minus 18 that is 32. Therefore k equals to 16 by 7. Now substitute the value of k. So we get coordinate of M, that is coordinate of foot of perpendicular. So replace this k by 16 by 7. So we replace this k by 16 by 7, this k by 16 by 7. So 16 into 2 we get 32 by 7, then 3k. So k is 16 by 7, 3 into 16 we get 48 by 7. So in this way we can find the foot of perpendicular. So in this way we complete exercise 5.4.